To our introductory video on probability. This is our final unit and our first lesson in this topic. The learning objective in this video is to build an understanding of sample spaces, events, and probabilities of events. Let's get started. Just to warm yourself up, try this problem here. Using proper notation, probability is usually given using this kind of symbol here. So this means the probability of some event, and in this case it's event B, or here would be probability of event Y, and you're supposed to use notation like that to give the probability of each of these situations. It says the spinner is spun once, imagine this was spinning here. What is the probability that it lands on blue? All right, hopefully you got that one right. You have noticed there are two blue spots here. These are all equal area. That's important to note. These all look like they're the same area. We have 2 out of a possible 6, which is 1/3 of this area here. If you spun this thing around here, so spinning, 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 1/3 of the time it would land on this blue here. So the probability of event B, meaning landing on blue, is 1/3. Complete the probabilities for all of these here, B to E. Okay, for yellow it was 1/6. For blue or white, or always means one or the other. Blue or white is 5 out of 6 because it covers 5 out of those 6 spaces. Blue or yellow is 1, 2, 3 out of 6, which is 1/2. And not yellow, not always means the opposite of being something. So if the probability of being yellow is 1 out of 6, then probability of not being yellow is 5 out of 6. Together, that 1 out of 6 and 5 out of 6 make 1. All right, so let's take some notes on the page that was provided to you in class. And let's begin with some vocabulary. A sample space is the set of all possible outcomes of an experiment. So imagine we're running an experiment like the rolling of dice or flipping of coins like we did in class. Sample space is basically a list or description of all the possible things that could happen in this experiment. For example, when you toss a coin, the two outcomes are heads or tails. So the sample space can be written in what's called set notation. Anytime we use this little squiggly bracket, it's called set notation. And the sample space is h comma t. So inside those brackets, we are writing this set of all the possible things that could happen. And there's the set. It is either we get heads or we get tails. Another example, list a sample space for choosing a random number between 1 and 9. So what do you think this sample space would be? Well, here is this sample space, but this is wrong. It says a number between 1 and 9, and it doesn't even say a number that is, if the number can be integer, it has to be an integer, if it can be a decimal number. But when we see between and 9, it should be written using greater than or equal symbols like you saw in the answer. This is not correct. Okay, C, a Greek. I was reading this word. A street vendor sells 2 types of sandwich, a South African Gatsby or a Greek hero sandwich, and 3 types of fruit, apple, orange, and banana. List the sample space for the possible choices of a sandwich and a piece of fruit. Well, here's a sample space for that. Here's our bracket with the squiggly brackets showing that this is the set of all the possibilities. One of the possible outcomes is the South African Gatsby and an apple. Another one is that same sandwich and an orange. Another thing that could happen is selling that sandwich and a banana. And then over here, now we have the Greek hero sandwich with an apple, the Greek hero with an orange, and so we have 6 things in the sample space. All right, try these then on your notes page. Find the sample space, or write the sample space for each of these, and let's give it a try now. Okay, so now 2 fair 6-sided dice are rolled. One die is green, another is orange, like we have here. Below the image below the image given, this one right here, is known as a sample space diagram. Oh no, wait, sorry, that's wrong. The sample space diagram will appear in just a moment. This is our sample space, but that might be kind of tedious to write all that. Well, here's our squiggly bracket, and you can roll a 1 and a 1, or a 2 and a 1 or a 3 and a 1, and all the possibilities are there. Another way to show that is in this table here. We have the orange die possibilities, the green die possibilities, and we write here in each of these. This would be a 1 in 1 rule, a 1 in 2, a 2 in 2, 3 in 2, and so on. All the things in the sample space are here. And here's another way. We have just an image of that to show what's going on here. All the possibilities are given in this diagram. This is probably the most common way to give sample space for this kind of large set of outcomes. So get used to this kind of table format. We'll be using that in different experiments we run. Okay, so based on that, try this one. The first question says copying complete. Don't worry about copying it. Do it right on your page, right? So you have this table here. This sample space table has the sum of the scores of rolling 2 4-sided dice. I don't know if you've seen those before. 4-sided dice, you can roll 1, 2, 3, or 4, and you're supposed to put the sum. So let's say this is die number 1, die number 2, and here you roll the 1, here you roll the 1, so the sum is 2. All right, and here you roll the 2, here you roll the 3, so the sum is 5. So go ahead and fill that in with all the sums. Okay, and now it says make a table to represent the sample space for the situation described below. So create a table, something like this, that might be used to show all the possibilities or all the possible outcomes for this experiment here. All right, so now let's move on a little bit. We're going to look at events and calculating probability of events. So we've talked about what a sample space is. Now we're going to look at what an event is. An event is a subset of the possible outcomes listed in the sample space. So event is basically, subset means a portion of all the possible outcomes. So if all the possible outcomes are listed, an event is saying, well, event A, for example, is 3 of those possible 10 things happening. So event kind of groups a little piece of the outcomes together. For example, we'll look at an example in a minute. Another thing you should know is that probability of event A is calculated by saying the number of ways event A can occur divided by the total number of possible outcomes. So this is like the sample space, and this is saying how many ways the event can occur. And the proper notation for probability is like this. So I know we started probability a little bit, but make sure from now on you use this proper notation. This means probability of event A means the number of ways A can occur over the number of possible outcomes in the sample space. All right, so probability of A represents the probability of event A occurring. And then this notation here, probability of A naught, this is read A naught, or the complement of A, this is called the complement, is the probability of A not occurring. And as we know, if we say there's a 40% chance I will eat lunch today, then there's a 60% chance I will not eat lunch, or a probability of 0.4 plus 0.6, and they make 1 together. Always, when you list all the possible outcomes, we're going to have 1. All right, so just so you know, there's been questions that are just kind of common in probability problems to have questions about a deck of cards. In case you don't know what a deck of cards looks like, it looks like this. There are 4 what are called suits. So these are the clubs, these are the spades, these are the hearts, and these are the diamonds. All right, and within those suits, 2 are black, 2 are red. Within the suit, we begin with ace, which often represents 1, or sometimes it represents a high card, and then we have 2 all the way through 10, and then a jack, a queen, and a king. All right, so now that you're familiar with those, let's try a problem like that. One card is randomly selected from a pack of 52 playing cards. Determine the probability that it is an ace. Going back to here, you look at this, you're like, well, how many cards is that in total? Maybe you want to count up how much you're in one row here. And then you have 4 sets like that. And here are your aces. So what's the probability of getting an ace? Let's look at here again. Probability notation. And we're going to define the event. So the event A is said to be an ace is drawn. So that's our event. So probability of this event happening, in other words, the event of getting an ace, is the number of what over the number of what? Well, that should be the number of the number of ways event A can occur over the number of ways that anything in the sample space can occur. And we know there are 4 aces, and in total there are 52 cards, because 13 in each suit, and that can reduce to 1/13. And that makes sense when you look back here, because it's 4 out of 52 ways to draw an ace, but it's also, if you break this up into a small set of just 1 suit, we have 1 out of 13 cards as an ace, and that 1 out of 13 applies to the whole group as well. Okay, so that's that solution, and that changes to a decimal. Often probability is just given as a decimal, and that is 0.077. Okay, now what is the probability that it is not an ace? First, we're going to define the event. As I said, we use this symbol here, which means not or complement of A, and event not A means an ace is not drawn. So probability of that would be probability of not A over the full sample. Now, if there was 4 aces, then there must be 48 cards that are not, so we have 48 out of 52. And that probability is a very high probability you will not get an ace. All right, the more practice, the better. So try the rest of the packet, do your best, and please come ready with any questions that you may have. You can do it.